let's prove the trigonometric equation. Cosine u minus v is equal to the cosine u times cosine v plus sine u sine v. So let's take the angle v up to the point B here, this angle. And let's take the angle u, which is from this position here up to the point D here. And if we subtract those 2 points, we're going to have u minus v, which is this angle here to the point C. And now this point, if we are mapping here in this circle, and if we want to find those distances between AC and BD, we already know finding the distances, AC is equal with the distance BD. So let me write here. So AC, the distance AC is equal to the distance BD. But we already know the formula for the distance is a square root. So just let me see here because I need those points to take. So we already know AC is, the distance formula is x2 minus 1. Those coordinates square. x2 minus 1 square is a plus y2 minus 0 square. And everything is equal with the distance BD. But the distance BD is equal with the x3 minus x1. Okay, so this is a x3 minus x1 square. Is a plus is a y3 minus y1 square. y3 minus y1 square. So we already know this. But now let's take a square root of both sides. If we are taking square root of both sides, so the index here is going to simplify. And what is going to remain is going to remain x2 minus 1 square. So let me do one extra step here. y2 minus 0 is a y2 square. And this is equal. So x3 minus x1 square. x3 minus x1 square. And is a plus y3 minus y1 square. And now let expand those binomials. And we have here x2 square is a minus 2x 2 times 1 is 2x2, and is plus 1 square is just 1 plus y square. And this is equal, if we are expanding all this binomial into trinomial, is going to be x3 cubic minus 2x1 x3 plus x1 square, and the other here is going to be y index 3 square minus 2y sub 3 sub y sub 1 plus y sub 1 square. So we are in this situation. So let me extend a little bit here. But now we already know here in the circle, if we are looking, in the x coordinate signifies a cosine x, and the y coordinate signifies a sine x or v in our case. But now if we have here, for example, x2 square plus, this is a y2, so I forgot to write. So if we are taking here x2 square plus y2 square, so this is a square, and this is going to be like a cosine square plus a sine square, because it is with the same index, is going to be equal with 1. This is a plus 1, and this minus 2x2 is going to remain in this side, minus 2x2. But again, here I'm looking what are with the same indexes but is a square. For example, x cubic square, and I have a y cubic square. So those two. I can write here a y cubic square plus x cubic square plus a y cubic square. Because those are going to be cosine square plus sine square, which is going to be equal with 1. And again, I'm looking here. I have x1 square plus y1 square. So if we are converting those in the terms of the trig function, is going to be 1. So we have x1 square plus y1 square. And what do we have else? Here remains minus 2x1 x3. And the other thing what remains here is a minus 2y1 y3. So let me put those smaller indexes first, than the largest in the back, y1, y3. And now this one here is going to be equal with 1. Again, And this x1 squared plus y1 squared is going to be 1. And this one here is going to be 1. And 1 plus 1 here is going to be 2. Minus 2x2. And here what it is, 1 plus 1, here is a 2. And what remains as is a minus 2x1, x3, and minus 2y1, y3. So it simplifies little by little. And in the end, we can subtract both sides of minus 2. So minus 2 here and minus 2 here. So this cancels. If we are subtracted, what remains a minus 2x2 is equal to the minus 2x1, x3, minus 2y1, y3. And now everything here divided by minus 2. If we are dividing everything by minus 2, now we have this term minus 2, this term we divide by minus 2, and the other term by minus 2. So minus 2 and minus 2 is simplifies is 1, positive 1 times x2 is x2. So we have x2. And on the other hand, again, this one we can simplify by minus 2 is a positive 1 times x1, 3, x1, x3. And here we divide minus 2 by minus 2 is 1. Same thing happened, and this is a plus y1, y3. And now we do this as substitution here. Let me go a little bit more. So x2, x1, so we are doing some substitution. x3, y1, and y3. Let me substitute with the trig function here. So if we are going back a little bit up here, so just let me go here and let me make a little bit more clear. So if I am writing, for example, at the point x1 here is going to be, with a v, is going to be cosine v, sine v. And x2, y2 is going to be cosine u minus v and sine u minus v. And here in the point D, because of this angle is u, and if we want to convert those points, for example, in terms of the trig function, is going to be cosine u and sine u. And now I'm going to make the substitution down. This substitution, what I already talked here, I'm going here to go down. So x2 is going to be equal with a cosine u minus v. And x1 is going, this is the first point, is going to be just a cosine u. And x3, this is the third point, is going to be cosine v. And y1 is going to be sine u, and y3 is going to be sine v. If we are substituting those substitution what we already have here, then x2 is going to be cosine u minus v is equal with a cosine u. x1 is a cosine u, and x3 is a cosine v, is a plus y1 is a sine u, and y3 is a sine v. So we already proved this trigonometric identity or formula. So the cosine u minus v is equal to the cosine u times cosine v plus sine u times sine v.